Biomechanical engineering is a subset of biomedical engineering.
Biomedical is more like putting an implant in your body and deciding how it's going to react with your blood or your rest of your bodily systems. But biomechanical is, well, how are we going to design that implant so that it can stand up to, everyday use?
It's any way that a mechanical principle, so you can kind of think of physics there, would be applied to the human body.
Anything you're doing to make the human being better.
Biomechanical engineering is sort of separated into three fields: clinical, occupational, and sports. For clinical, you can better understand diseases such as MS or autism. For occupational, you can design a safer and more long-term healthy workplace. And for sports, you can design a better push-off block for an athlete. You can help reduce the number of concussions a football player is going to get by designing a better helmet.
I thought engineering was only about designing cars and building robots. It's not. Biomechanical engineering is a really up and growing field because there's more need, especially in the clinical field. Physical therapists have been around for a very long time, and now they're starting to realize that working in conjunction with an engineer can really help bring more objective measures to their practice. Some neat jobs that some of my recent students have gotten include working at Prosthetic Design, a company that designs artificial limbs. You could also do things like become a lab director, lab coordinator at a motion lab, so putting the markers on people. That could be for sports reasons, research reasons, even a movie studio. I have a student who designed baby equipment and gear, and so when I had my baby and was looking at products, she said, "I designed that and it's in the stores." So different things like that are always available.
I don't speak well, but this is a good idea.
Belinda Isaac, our rehab manager, had the idea to contact the Innovation Center and UD and the biomechanical engineer students for this project to see if they can make devices that we can use with our patients with the iPad.
I love it.
Yeah, that's the whole point.
Yeah.
That's why we worked with those guys at
Yeah.
UD to do that.
Yeah.
In high school, I knew I kind of wanted to be an engineer because I was interested in making things, and I thought that was really cool.
I didn't ever know I wanted to be an engineer at all to start with. I really wanted to be a teacher for special education and working with children with disabilities. That was really something that I wanted to do, and I didn't know at the time that engineers can do things like that.
It's an opportunity to do something for the human being, to do kind of those cool science fiction things that you see in the movie and make them a reality. Finding ways to have people interface with machines and computers. I mean, it sounds science fiction, but that's becoming more of a reality.
To me, for an engineer to be able to help children with disabilities, to work with doctors, to work with physical therapists, I was just sold at that point in time. I wanted to be someone that would design prosthetic limbs and evaluate how a child with cerebral palsy walks, and all of those things that I have gotten to do. That was my motivation for becoming an engineer. So anytime you talk about engineering, you're talking about STEM. Engineering is the E in STEM.
There's a little bit of biology and anatomy. There's a lot of math. There's some physics involved.
Things that you learn in books, which aren't always as exciting, but taking it to something that's real.
If you're interested in becoming an engineer in general, but specifically biomechanical engineering, it kind of starts in high school, and that's when you want to take as many science and math classes as you can.
I think my last one was AP Calculus. I took AP Physics. I took Chemistry.
Trigonometry, where you're talking about sines and cosines. I use that all of the time when we're trying to find out the angle that someone's leaning or the angle that a knee is at while walking. Biology is definitely a root of biomechanical engineering, and so you want to take that, anatomy, physiology, if those are offered. As an engineer, you will write a lot, and so you want to practice that.
Learn teamwork skills. At least as an engineer undergrad, you do a lot of working together in teams, you do a lot of homework together.
You'll find that most institutions that have a mechanical engineering department will have biomechanics to some degree. When I was looking for schools, I just emailed the department and said, I know I'm interested in biomechanics. Do you offer that within your program? And if not, is there another program in your school that does?
So if I want to go master's, I'll be on a 2.5 year plan. I'd probably go into industry then. If I do PhD, it'll be a 4-year process. I'm already a year in. After then, I could either, again, work with companies or I could actually go into academics.
I absolutely love biomechanical engineering, and it's because I get to deal with people. I can work with physical therapists and doctors and physicians and people in the clinical side, but then the patients come in, and that's why I took this career path. The ability to innovate is becoming so important, to be unique in what we design and help satisfy needs of different people, and all of that comes from engineering.